Okay, so can anyone see my screen with no problem? Like this is the screen that you can see, like over here. Um, yes, and good. And everyone can hear my voice. So I think we're like set up successfully. Okay, so a few announcements. First of all, homework 19, 20, and 21 are up. So they're due Thursday by 11:59 a.m. And second of all, quiz, it will be on Thursday. And also like is the homework due tonight? I'm not aware of that. But like currently I set up the due time to be Thursday. I don't know. I guess I'll just give you like a bit more time if that's the case. So be sure to submit your homework Thursday by 11:59 a.m. It's not p.m. It's a.m. So like due by noon. So noon. Quiz A will be on Thursday. Be sure to submit that, and then like you guys should be able to access your score of quiz 7 and homework that you submit. So like if you have a problem on like accessing your score, please ask me. And also if like since like in B course I have like no I don't know how to tell you like why are you missing, or like not getting like the score you want. So if I have a problem, you can ask me. And yeah, I think that's it. The average for this quiz is about 8 for both of my sections. And medium is also like roughly 8. I forgot 8 or 9, but like some number in between. Yeah, and also like the reason why a lot of people lose points is because I grade a little bit harsh on problem written problem 1. If you like, so like for written problem 1 there's like 4 points. If you didn't plug in the Poisson correctly, you will lose 3 points. So I'm also like thinking about if I want to give opportunity for a quiz correction for this quiz. Yeah, I haven't decided yet. So if I decide, I'll probably make an announcement. And yeah, so I guess like most of you are here. Okay, so people are actually want a quiz correction. Yeah, I mean, I haven't decided yet. Yeah, I will definitely post the quiz solution, and also like yeah, I think I don't need to go through the quiz during the class. I've already written the quiz solution explicitly. Oh wait, yeah. If I post a quiz solution, how would you get to do a quiz correction? That's also like something I need to think about. So yeah, I'll probably not going through the quiz right now to see if I want to like decide to give you a quiz correction. Yeah, that's actually a good point. So Yeah, I mean it's hard in big course because I can't give like comments on each question. I can only give like a comments in total. Like I'm not like writing down all the like reasons for each of you why are you um like getting the points and not getting the points. Um so one thing I'm thinking about right now is that I'm not giving you the quiz solution now. And I will let you guys do a quiz correction, and then I will probably release the solution on Thursday. That's what I'm thinking about. Also, in the future, I might want to like do some research on Gradescope, to see like if it's okay for us to all like submit our quiz on Gradescope, so that I can make like rubrics on whether you lose points because of what and what, and then also you can do a regrade request on Gradescope. That's what I'm thinking about right now. But like it also depends on like situation and whether like um everyone like every other JSI are coordinate with me to use the same system. So that's definitely something I want to like report. Yeah, and also like I will be recording this video. So in case if you didn't fully understand or didn't fully follow the solution or the question, I will post the video of this 1 hour and 20 minutes to the B course, so that we can go to like whichever question you have problem with and we watch the video. So I guess that's more beneficial for all of us. And also for those who just arrived, there's a form that you have to fill in for me to take attendance if you haven't filled it already. And there is another form. I don't know where it is, but like this is kind of like a form from professor that you guys need to like fill it in for if you have a time conflict on quiz and exams, because some of the students are leaving out of town or like even going to another country. So there might be like time zone difference in terms of taking the quiz and taking the exam. So that's something that's worthy to address. So I'm also like submitting the link, and also like, can anyone tell me how do you join the room? What's the link for my room? Because one of my students want to join the Zoom and has no idea how to join. Okay, so you basically just write down this number and then okay. So I'll just tell him that this is my Zoom number. Yeah, okay. So tell him that my Zoom number is this. Thanks for telling me my Zoom number. And I think you guys should be able to access the worksheet. So yeah, so basically we spend 10 minutes on logistics, and then I will do like plan for today. Oh, and also like a student from my previous section told me that sometimes the screen gets stuck, it gets frozen. So like if that happens, be sure to remind me and send me messages so that we can like make sure that everyone is good, including me. So plan for today. So we will go through a review on covariance and IID random variable. IID stands for independence and identically distributed distribution. Yeah, we'll do a review on that. And theoretically, we also need to do limit theorem. But according to what just happened last section, we apparently don't have enough time to do the limit theorem. So we'll probably do that on Thursday because we probably don't have time on doing that. And then there will be like some new material on Thursday. If I didn't finish all the materials on Thursday, for the remaining thing that we didn't finish on Thursday, I'll probably do record a video myself and post it on the B course that is specifically for my own 2 sections. So like you guys can look at this. And also, in fact, I feel like this is kind of a better way to do the class, because you can look at the videos. Like as long as you're like not skipping all the discussion, or you're not like skipping classes, you're fine. Like because whenever you have a question, you can look at the video and then reiterate the thing. Okay. So first of all, let's review on covariance. So let me go to my notes on covariance. So covariance. So what is covariance? Covariance is a measure. Of how far from independence that 2 variables x, y are. Algebraically, it's defined to be the covariance of x, y is equal to the expectation of x, y minus the expectation of x times the expectation of y. But one thing I want to highlight is that one thing I want to highlight is that so if we have x, y are independent, we can get that means the covariance of x, y is 0. But if the covariance of x and y is equal to 0, it's not necessary for us to get x, y independent. So this is like a one-way statement. Like usually students are making mistakes here. And then I'm just going through like why are we defining covariance algebraically like this way. The reason of that is because for any random variable x and y, the variance of x plus y is defined to be variance of x plus variance of y plus 2 times covariance of x, y. So like covariance is defined to be there. Yeah. So so that means like if and also we also from previously we know that if x, y are independent, we can directly write vx plus y equal to vx plus vy. That's when x, y are independent, and that means the covariance of x, y equal to 0, which makes sense because so like this is for general x, y, this is for x, y independent. That means like the covariance of x, y are 0. And also like covariance, the smaller the covariance is, that means they're like x and y are less dependent with each other. The larger covariance of x, y is, that means they are like very dependent with each other. So that's covariance. And IID stands for independent, and so we need to like do independent and identically distributed. So for this, so like don't be confused with independence and identically distributed, because like for independent, we are like just working on two events itself, whether one event will affect another. So it's basically the probability of event X doesn't change if or not the event Y happens. That means like we're talking about independence, and for that we're usually doing like the event of A and B is equal to the event of A times the event of B to check independence. And for identically distributed, that means for each event, or for each random variable, we want to say like if that random variable follows the curve, like follows the same distribution. So one thing good about identically distribution is because I'll explain like if we write the random variable x into I1 plus I2 plus up into In, which is like n random variables, when Bernoulli random variables that follows the same distribution. If you want to find the expectation of x, that's just the expectation of I1 plus dot 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 plus In, which is because the linearity of expectation, that's just I1 plus dot 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 plus the expectation of In. Because so this equal sign is because of or this equal sign is because the linearity of E, and then we can write as n times expectation of I1. So this equation here is because I1 to In is identically distributed. And as for variance of x, so that's how like identically distributed is useful. And another example is the variance of x bar. So where x bar is defined to be x1 plus dot 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 plus xn over n. If you want to calculate that, we need to do two things. We need to do like several steps. The first is that we can write it as n squared over 1 times the variance of x1 plus dot 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 plus xn. We can do that. So this equation here holds because the variance of ax plus b is equal to a squared of variance x, where like a, b are constant. And then we can like but like for variance to be written, variance x1 plus up to xn to be written in the form of variance of x1 plus plus xn, variance of xn. So if we want to write it in this way, we have to have the condition that x1 to xn are independent. And then if you want to write variance of x1 to variance of xn equal to n times the variance of x1. That means we need random variable to be IID to get that. And then at last, we get the result that the variance of the x bar is what. Okay, so there are some questions here. Is IID random variable are copies of original random variables? So you can think of in this way. So theoretically, we are like for each random variable, they are defining different events. But if their distribution are the same, algebraically we can manipulate it in the same approach. And square root of n, I think you are talking about x bar, like the, I don't know what you're talking about. No, it's over n for variance. And again, like variance is the is sigma square, and standard deviation is sigma. So like you are doing over n for you're doing over n for sigma for variance, and you're doing like demand over square root of n for SD. So like be sure to know that. So I'm just like writing down an example from the lecture. So the question is variance of x bar equal to Vx over n? Yeah, the variance of x bar is equal to n times, like it's equal to Vx over n, which is the sigma squared over n. It's also in the lecture notes if you want to like have a more detailed look on the problem. So ID shows even if it shows. So remember, like IID random variables are independent and identically distributed random variables. They're not necessarily to be like each random variable is not necessarily to be a Bernoulli trail. It's just like right now the only example we look at are Bernoulli trails are like independent of each other, and also if we write them in terms of indicator, they are like distributed in identically. So that's why we call each random variable for each random variable for each Bernoulli trail in that case identically distributed. But like it can be like other random variables that follows the same idea of identically distribution and independence. We still call that IID. So I think it's good if we can do more practice problems. So maybe work on problem 1 on your discussion worksheet. And also like feel free to ask any question if you have one. Problem 1 on covariance and IID random variables. And also you can like send me a message privately if you finish problem one, so I know like the progress of us. Yeah, just for some.
Wait, see how?
Oh,
Hi. I have a question. So I know I asked about this like previously, but like, how is it that um these variables should be dependent, right? Because the
for problem one?
yeah, for problem one.
Oh, yeah.
But then the expected value still is the same. Um, like I still don't understand why that is.
I will talk about it in detail. Like I will go through
Okay.
the solution for this problem. Yeah.
Oh,
So like maybe just work on the other problems first.
okay.
Yeah, if you finish problem one, work on problem two. We have like a lot of work on problem two, and most likely you can't like finish the problem of problem two. That like you don't have like too much time on problem two. Like problem two is like a page long, and the solution are like 5 pages long. Okay, so I'm going through the solution for problem one. So problem one says we draw 5 cards out of 52 cards without replacement, and let um x1, x2, x3, x4, x5 to be the rank of cards from 1 to 13. So are these random variables identically distributed? Are they independent? So first of all, they are identically distributed because we're talking about so we are like x1, x2, x3, x4, x5 are like from the perspective of each position of the deck of 5 cards in my hand. So like there are position 1 to 5 in my hand. So this question is same as like say if I draw five cards on the top of 52 cards with any like random order. It's same as like if the position of the second card in the deck of 52 cards are rank of what. So this should be the same for each position. The probability of getting a number, a rank for each position should be the same. So if we write it formally, that would be I is in 1, 2, 3, 4, 5. So if we're talking about random variable xi, the PMF is given by fk is 4/52 for k is in 1 to 13, because there are 4 cards out of 52 cards for each rank. And are they independent? No, they are not independent. Because for example, the probability of drawing an ace on the second draw depends on whether or not the first draw was in the first, or the first ace, the first draw has an ace or not. So a lot of students are actually confused with identically distribution and independence. Identically distribution we are just in the topic of random variable, the event itself. But for for independence, we need to look at whether events can affect each other or not. So if we write it formally, we need to give like a counter example on the independence. So a counter example can be the probability of x1 equal to 1 and x2 equal to 1 is 4/52 for choosing the first card to have an ace. And for the second card to be ace, it's 3/51. But the probability of x1 equal to 1 times the probability of x2 equals 1 are 4/52 times 4/52. And these two are not the same. So that means the random variable x1 and x2 are not independent. So this question is a very good example of identically distribution, but not independent. And there are also like a lot of examples of independent, but not identically distributed. So be sure to understand the definition. And then please work on part A of problem 2. Yeah, or part A and part B if you think part A is too easy. And also, I just want to emphasize that for those who just joined the chat, please fill out the attendance form. That's the way you can be like graded for attendance. If you like attend the section, but like you didn't write out the form, I have no idea like you are in the section or not. So be sure to write that down. So that's the first form for attendance. And there's another form. This is the second form for time conflict. Conflict on quiz/exam. Yeah, definitely fill out the attendance form once. Yeah, and don't fill out the attendance form for others. I just realized this problem. Like I didn't set up restriction on like this is anonymous. So theoretically, you should have you can like fill out the form for like everyone in the class, but like don't do that. Just like fill out the form for yourself. Yeah, and yeah, but like you only need to fill out the attendance form once, but like the time for me to send out the form in the future might be arbitrary. So like, I mean, theoretically, if you fill out the form, you can leave. But like, since we are actually discussing a lot of problems, and I feel like the problems we're going through today is worthy to talk about. So, I mean, it's up to you to leave or not. And also, again, if you finish 2A, please send me a private message. If you finish 2B, good. Also send me a private message so I know like when should I go through the problems. Okay, some students have sent me a message about finishing 2A. But like most of you haven't sent me any message about that. So I will still like wait for some minutes. For those who have already finished, please work on the problems afterwards. Okay. It looks like most of you has some progress on 2A. So I'll just go through the solution for 2A together. And one student suggests me to use a secret pen. I think that's a good suggestion. So I will change the size to be a little bit thicker. Yeah, maybe too thick. Yeah, I think this is good enough. Okay, so for problem 2A, or for problem 2 itself, let me just like look at it. So x1, x2, x3 are the result of four-sided row, or like the row of four-sided die. And we define x to be x1 plus x2 plus x3. And we define y to be x1 plus x2. We define x bar to be x over 3, which is x1 plus x2 plus x3 over 3. And we define mu to be expectation of x1, and we define sigma squared to be the variance of x1. Okay, so for part A, what's the range of x1, x2, x3? Because x2, x1, x3 are all measurements of results from a four-sided die. So the range of them are all 1 or 2 or 3 or 4. And the x, the capital S, x is defined to be x1 plus x2 plus x3. So the minimum of x is 3. It comes from 1 plus 1 plus 1, where when x1, x2, x3 are all 1, and the maximum of x is 12. It is when like x1, x2, x3 are all 4. Yeah. So the range of x are from 3, 4 up to 12. And for x bar, it's basically doing multiplying 1/3 on the range of x. So it's just 1, 4 over 3, 5 over 3, 11 over 3, and 4. So that's the range of x bar. And the range of y is defined to be x1 plus x2. So the minimum of this is 2. It is when x1 and x2 are 1. And the maximum of that is 8. It's when x1 and x2 are 4. So that is not hard. Okay, then let's move on to part B. So for part B, we want to calculate the variance. So we want to calculate the variance of x1, x2, x3, x bar, and y. So remember, like, for calculating a variance of a random variable, we always want to use the definition that, or the equation that variance of a random variable, let's say a, is equal to the expectation of a squared minus the expectation of a, the whole thing squared. So for x1, the variance of x1 is equal to the expectation of x1 squared minus expectation of x1 whole thing squared. So what is expectation of x1? Expectation of x1 is defined to be the summation of in the range times so like the x is in the range, so it's x, the probability of x1 equal to x. So in this scenario, that is just 1 is in the range. It has like 1/4, so row a 1 out of 1, 2, 3, 4, 1, 2, 3, 4. And also 2 has 1/4 possibility to be rolled. 3 also has 1/4 possibility to be rolled, and 4 also has 1/4 probability to be rolled. So that's a uniform distribution, and the result of expectation is 5 over 2. And similarly, for expectation of x1 squared, we just plug in x1 squared into the equation. So for x in the range of x1, this is equal to x squared times the probability of x1 equal to x, which is 1 squared times 1 over 4 plus 2 squared times 1 over 4 plus 3 squared times 1 over 4 plus 4 squared times 1 over 4, which is 16 over 2. So the variance of x1 is equal to this and we just simply plug in the number, and the result is 5/4. So that's the answer for variance of x1. And since x1, x2, x3 are identically distributed, because like x1, x2, x3 are just kind of like trial, are like 3 attempts on measuring the result of a row of four-sided die. So they're identically distributed. They're all like uniformly distributed. So the variance of x1 is equal to the variance of x2 equal to the variance of x3. It's 5/4. Okay, so that's for x1, x2, x3. And then we need to find the variance of x. So x is defined to be x1 plus x2 plus x3. And we know that x1, x2, and x3 are independent because the result of my first row, the result of like one row doesn't affect on another one. So similarly, the distribution of one random variable does not affect on the other random variable. So if you want to calculate the variance of x, that is just the variance of x1 plus x2 plus x3, and it is equal to variance of x1 plus variance of x2 plus variance of x3, and this equation holds because the independence. So the result is 15/4. Okay, a student asked a question: what is the case when x2 when the three random variables are not identically distributed? So I mean, like usually it's very intuitive if they're not identically distributed. If like they're measuring even things, like most likely they're not identically distributed. Like identically distribution is very specific. Like it has to be like measuring the same thing, but like in different scenario. Because like x1 is basically a measure of like x1, x2, x3 are measured the same thing. They're all the result of a four-sided row. Yeah, for example, like the distribution of me talking about which problems versus a result of four-sided row. These two distributions are definitely not identically distributed. So like if they are not identically distributed, it should be like pretty obvious. Okay, let me know if you have more questions. So next is the variance of x bar, and x bar is defined to be x1 plus x2 plus x3 over 3. And like recall that variance of ax plus b is just variance, it's just a squared times variance of x. So this 1/3 is the constant in front of a random variable. So we can take out that as 1/3 squared, which is 1/9, over variance of x1 plus x2 plus x3. And we know that this is equal to 4/15. So the result of variance of x bar can be calculated easily. And finally, we're talking about y. We want to find the variance of y. Variance of y is equal to variance of x1 plus x2 by definition, because y is x1 plus x2. And since x1 and x2 are independent, that's just variance of x1 plus variance of x2. This equation holds because of independence, which is 5/2. So you can like work on part C yourself now. And if you have questions, please ask me. Yeah, work on part C, and if you finish, just continuously working on the problem after that. But that was like, this question is pretty long, so I guess like now you have to finish it right now. And again, let me know if you like, let me know your progress, like which part are you on. If you like finish part C, you can also tell me like if you are in part D or E or something like that. Just like tell me your progress. A hint for doing covariance matrix is that doing covariance is that so like remember the definition of covariance of A and B is just the expectation of AB minus the expectation of A times the expectation of B. So if you don't know how to start with this question, like start with the definition of covariance and see if you can do it algebraically. Let me know if you guys finish part 3. Yeah, also like you can ask me questions if you are like having question on working on part 3. Okay, so let me go through part 3. So for part 3, we want to calculate the covariance of x1 and y. So according to the definition of covariance, we can write it as expectation of x1 y minus expectation of x1 times the expectation of y. So that is equal to so we can like write y in terms of x1 plus x2, because y is defined to be x1 plus x2 in this question. So that's just expectation of x1 times x1 plus x2 minus e of x1 times e of x1 plus x2. And then we can do some like algebra to expand the parentheses. So that's x1 squared plus x1 x2 minus x1 times e of x1 plus e of x2. Like we can write that because the linearity of e. And again, we can write this in terms of e of x1 squared plus e of x1 x2 minus e of x1 e of x1 plus or minus e of x1 e of x2. So let me like simplify this equation. So that's e of x1 2 minus e of x1 the whole thing squared minus e of x1 e of x2. And remember that x1 x2 are independent. So we can write this as e of x1 times e of x2. So the equation becomes e of x1 squared plus e of x1 plus e of, times e of x2 minus e of x1 squared minus e of x1, e of x2. So these two terms canceled off. The result is just e of x1 squared minus e of x1, the whole thing squared, which is 5/4. So that's the result for covariance of x1, y. And for covariance of x3, y, we can do the similar manipulation as what we did before, like plugging the equation that is equal to the expectation of x3y minus the expectation of x3 times the expectation of y. And you can like do it by yourself. The algebra idea here allows you to get 0. But why is it 0? So again, like if we look back into the definition of covariance, the covariance is a measurement on the measure of like independence between two random variables. And we know that y is equal to x1 plus x2, and x3 is x3 itself. So y has no relationship with x3, and actually y and x3 are independent with each other. So the covariance of y and x3 is 0. So that also answers the question for part D. Is x1 and y independent? It is for x1 and y is not independent. Its covariance of x1 and y is not 0. But like x3 and y is independent. Yeah, it's independent. So that's like part D. So for the rest of the time, please work on problem E and F. I'll probably leave you like 2 or 3 minutes on that. Or actually, I will go through part E. Part E is easy. So part E is also like something we went through during the class. We let mu bar equal to the expectation of x bar. And we let sigma square bar is the variance of x bar, and we define z to be x bar minus mu bar over sigma bar. And we want to find the expectation of z. So we know the expectation of z, the only information we have of z is over here, is equal to x bar minus mu bar over sigma bar. And also like because of the linearity of expectation, we can take this constant off. So that's just mu bar, 1 over mu bar, and e of x bar minus mu bar. So this is equal to the 6, it's a sigma. Bar of e of x bar minus e of mu bar. So remember, like the expectation of a constant is just a constant itself. So this is equal to mu bar. And also from the definition, we have our expectation of x is also a mu bar. So the expectation of z is 0. And for variance of z, it is equal to the variance of x bar minus mu bar over sigma bar by definition. And if we still recall the variance of ax plus b is equal to a squared times the variance of x, so we can get this constant odd, which is sigma bar over 1 squared times the variance of x bar minus mu bar. And also like it's just a constant, like mu bar is just a constant, so it doesn't affect on variance. So we can get rid of that immediately. And also like our definition of variance of x bar is just sigma bar square. So if we times these two together, we get 1. So as you can see, if we standardize a random variable into z equals to x bar minus mu bar over sigma bar, that's how we like standardize. And we always have mean equal to 0 and variance equal to 1, or like SC equal to variance equal to 1. But SC is just like square root of 1, which is 1. Okay, seems like there's some question over here. Will the covariance of x1, y always be equal to variance of x1? I mean, it just like depends on the question, right? So for now, we define, like we are defining random variable x1, x2 to be a uniform distribution, and y equal to x1, x2. So in this case, that works, but like in other situations, it might not work. Did we learn that what to do e of xy if they are not independent? No, I don't think we learned that. The only thing we learned that when they're not independent is when there's like two die or something, and then they list specifically for each x and y in their range, what will their distribution be for e of xy on one of the discussion worksheets. And the solution for C set goes from since that's independent, and you can factor this one. Okay, that might be an answer for that. Okay. It seems like Jenny are answering the question for me. Thank you very much. So wait, how do you go from variance of x minus m? Cause like if you look at the random variable x, it has a distribution. And if you plus or minus any constant, it's just like shifting the distribution to left or right. It doesn't change the spread or the variance of the distribution. So the variance of x, so the variance of x minus a is just variance of x, and the variance of ax plus b, like similar here, like we just get rid of b directly, is equal to the variance of ax, which is the a squared times the variance of x. Yes. So I think I have answered all the questions, and I guess I don't have time for you to solve last problem by yourself, so I just go through the problem for part F. So for part F, what is PMF for Z? So for this question, we always need to find the range of Z first. Because like we are talking about from the perspective of a random variable Z instead of X. So look at the definition for Z. What is Z? Z is X bar minus mu bar over sigma bar. So we know that sigma bar is a constant, mu bar is a constant, only like X bar is a variable. So the range of Z depends on range of X bar. So what's the range of X bar? It is 1, 4 over 3, 11 over 3 and 4. This is like an average of x1, x2, and x3. And from previous process, we also get sigma squared bar is the variance of x bar. It's 5 over 12. That's something we did before. And mu bar is the expectation of x bar, which is just the expectation of x1 plus x2 plus x3 over 3, which is 0 over 1 times the expectation of x1 plus x2 plus e of x3 plus the linearity of expectation, which is just 5 over 2. So we have this information here. And then we need to look at what range of z is. So range of z. So it's basically applying the equation that z equals to x bar minus e bar over sigma bar on the range of x, here. So the range of z after calculation is -3 over 2. -7. So that's just like calculation on each. For example, here we just plug in 1 to as x here and plug in these two constants to here and get this result. And similarly, we can plug in all the range of x to get the result. So at last we get something like that. So that's range of z. And then we want to find the probability distribution of z. So remember, like this corresponded to like x bar equal to 1, and this corresponded to x bar equal to 4 over 3, which corresponded to x1 plus x2 plus x3 equal to 3. This corresponded to x1 plus x2 x3 to 4. It's just like 3 times this x bar here. Yeah, so if we are looking for each value of z, the probability of each value of z is similarly, it's just as the same thing of looking. So let's say if we want to find p z equal to 1 over 6 over square root of 5 over 12. So that's like one of the possible value in the range of z. This is just the same thing as finding x bar equal to 3 over 8, because if you plug in 3 over 8 minus the mean over the standard deviation, you will find that the standard deviation is square root of 5 over 12. You will get the result here. So that's a similar probability of finding that, and that's just a similar probability of finding x1, x2 plus x3 equal to 8. So what are the ways for our try to get the sum of 8? It can be 1 plus 3 plus 4 to get 8. It can be 2 plus 2 plus 4 to get 8. It can be 2 plus 3 plus 3 to get 8. So there are 3 factorial ways for us to map 1, 3, 4 into random variable x1, x2, x3. So that's just 6. And there are 3 ways to get. There are like 3 choose 1 ways to map 2 to 4 into x1, x2, x3, because we can assign 4 into any of random variable. And there are also 3 ways for 2, 3, 3. So this sub question is how to find x1, x plus x2 plus x3 equal to 8 for x1, 2, 3 in the range of 1, 2, 3, 4. So we find that there are 12 ways of getting the sum of 8, which means that there are 12 ways to get x bar equal to 8 over 3, which means that there are 12 ways to find z equal to 1 over 6 over square root of 5 over 12. But this is out of what? How many ways? It's out of like 64 ways, because for each random variable x, there are like 4 ways to choose from 1, 2, 3, 4. So in total, there are 4 to the third, which is 64. So the answer of probability distribution of z equal to 1/6 over square root of 512. It's just that, or it's also like same as the probability of distribution of x1 plus x2 plus x3 equal to 8. And you can also do the same thing on different z's, which is equal to different x1 plus x2 plus x3 from 3 to 12. Like after doing all those probability distribution and listing all the probabilities, your result is the probability mass function for z. All right, that's it for this discussion. And for quiz 8, it will cover anything before covariance, I think, including covariance. Yeah, and just let me know if you have like a last minute. Yeah, there will not be limit theorem on the quiz. Yeah, but like theoretically, limit theorem is just like a normalization, but there might be like a normalization problems. Yeah, but like I don't personally think that counts as in the scope of limit theorem. So if you haven't filled out the attendance form, definitely fill that before you leave. And I will wait 1 more minute if you have last minute questions. Okay, it seems like no one has any last minute questions. So I guess I will just end my discussion. And hope to see you on Thursday.